All right, let's talk C++. If you're like most of us, your go-to container is std vector, right? I mean, 99% of the time, it just works. But what about that other 1%? Is it always the best tool for the job? Today, we're going to look beyond the default and figure out how to pick the perfect container every single time. So let's get into it.
So, let me ask you this. Have you ever been in a situation where you need to add stuff to the very beginning of a big collection, over and over and over again? If you're using a vector for that, well, you might be hitting a performance wall without even knowing it. Yeah, that simple little add to front operation, it can be a huge hidden bottleneck.
Okay, so here's the game plan. First, we'll break down exactly why vector struggles sometimes. Then, we're going to meet three awesome alternatives: the deque, the list, and its leaner cousin, the forward underscore list. We'll even see them in action with a real-world coding problem, and then I'll wrap it all up with a super handy cheat sheet you can use in your own projects. Sound good? Let's go.
All right, first up, beyond the vector. Let's really dig into the problem with our default choice.
Okay, so here's the dirty little secret of std vector. When you want to stick a new element at the very front, it's not a simple little operation. No, the vector has to take every single element that's already there and scoot it over one spot to make room. Think about that. If you have a million elements, that's a million separate moves. In big O notation, we call this a linear operation, or O of n, and trust me, it can get painfully slow.
So, if front insertions are a problem, what's the solution? Well, what if you really need to do a lot of work at the front? This brings us to our first specialized tool. Let's meet the deque.
The name pretty much gives it away, right? A deque is a double-ended queue. Its entire reason for existing is to be blazing fast when you're adding or removing things from either the front or the back. That's its superpower.
So how does it pull this off? It's all about how it handles memory. See, a vector is like one long, solid table. Everything has to be side by side. A deque, on the other hand, is more like a train. It's made up of a bunch of smaller, separate cars, or blocks of memory. So when it needs to grow, it doesn't have to rebuild the whole table. It can just hook up a new car to the front or the back. Super efficient.
And this is what that gets you. The big win? You get constant time, that's O of 1, operations on both ends. That's amazing. And you still get that fast O of 1 random access, just like a vector. So what's the catch? Well, it's still slow if you try to insert things in the middle. And because of that train car structure, jumping to a specific element is just a tiny bit slower under the hood. But honestly, if your work is all about the front and the back, deque is a no-brainer.
Okay, so deque totally solved our front-of-the-line issue. But what if your bottleneck isn't at the ends at all? What if you need to be able to stick things in and pull things out from anywhere in the middle of your sequence and do it fast? For that, we need a totally different tool. And that tool is std.list. Now, this one thinks completely differently. Forget about big blocks of memory. A list is made up of individual little packages called nodes. Each node holds your data, but it also holds two little pointers. Think of them as arrows. One points to the next node in the sequence, and the other points back to the previous one. And this is where the magic happens. To insert a new element, you don't have to move anything, not a single thing. You just create a new node, and then you just rewire the pointers. You tell the node before it to point to the new guy, and the node after it to point to the new guy. It's literally like adding a new link into the middle of a chain. It's a constant time, O1, operation. And it doesn't matter if the list has 10 elements or 10 million, it's just as fast.
But, and this is a big but, there's always a trade-off. In exchange for that amazing flexibility, you give up something huge. Because all the nodes are scattered around in memory, there's no way to just jump to the 500th element. You can't do it. To get there, you have to start at the beginning and follow 499 of those next pointers one by one by one. So you get incredible insertion power, but you completely lose that fast indexed random access.
Okay, so you love the idea of the list, but maybe you're working on an embedded system or somewhere where every byte of memory counts. Well, C++ has got your back with an even more specialized tool.
Let me introduce you to standard forward list. It's a singly linked list. The idea is exactly the same. It's a chain of nodes, but this time each node only has a pointer to the next element. There's no previous pointer. You can only go forward. It's a one-way street, no turning back.
Now, why on earth would you want that? Simple. Memory. By ditching that previous pointer, every single node gets smaller.
This makes forward list the absolute most memory-efficient linked container there is. So if your job is just to process a sequence from start to finish, and you need those efficient insertions along the way, this is your lean, mean, memory-saving machine.
Okay, that's a lot of theory. It's great to know this stuff, but how does it actually look in the real world? How do you know when to pull which tool out of the toolbox? Let's look at an example.
So we're going to take our example from a competitive programming site called Kattis. The problem is called overnight oats, and helpfully, the problem description itself kind of gives you a massive hint. It says, use a deque. Let's figure out why.
It's because the problem is a perfect model of a double-ended queue. You do one thing at one end, you add oats to the container at night, and you do a totally different thing at the other end. You eat the oats from the container in the morning. This is the exact scenario where a deque just crushes it, fast at both ends. Using a vector here would be clumsy and slow. It's a textbook example of picking the right tool for the job.
Wow, we've covered a ton of ground. So to bring this all home, let's boil it all down into one simple practical cheat sheet that you can mentally refer back to.
And here it is. This table really tells the whole story. Look, if you need that instant, indexed, random access, you're looking at vector or deque. If you're constantly adding and removing from the front and the back, deque is your champion, hands down. But if your pain point is inserting and deleting stuff right in the middle of a huge sequence, list is your answer. And finally, if you need that middle insertion power, but you're also counting every byte of memory, that's where forward list comes in. It's all right here.
So the next time you're about to instinctively type std data vector, just pause for a second. Ask yourself, what am I really doing with this data? Am I adding to the front? Am I inserting in the middle? By understanding these trade-offs, you can go from writing code that just works to writing code that is truly elegant and efficient. So what's the right tool for your next job?